So I would like to do some proofs which I did in the online class. Uh, for example, you'll be asked to find if P of A in B uh, should be proven to be P of A plus P of B minus P of A intersection B. This is true if A and B may not be mutually exclusive. And if they are mutually exclusive, there's another formula: P of A union B equal to P of A plus P of B. So these two formulas I'll try to tell you how it is solved. So uh, let let us look at this Venn diagram. Let's say this is the event A, this is the event B, and let us say there are uh, P number of elements in A, Q number of elements in B, and there are a few elements here. Let's say that is M. So N of A is equal to P, N of B is equal to Q, and N of A intersection B is M. So now by definition of probability, let's say sample space is S and S has got N elements, then P of A is clearly what? P divided by N. P of B is Q divided by N. And P of A intersection B is M divided by N. So, what is A union B? A union B is set of all elements such that X is in A or X is in B. That means N of A is N of A union B is this set of P plus Q minus M, right? So if you want to find probability of this event, combined unit event A union B, it is N of A union B divided by N of S, which is what? P plus Q minus M divided by N. Okay. So maybe this is confusing that what is I'm using the same N both, so I'll color it in a different way. This yellow N is the number of elements in this. Okay, and this white N is uh, the sample space elements. Okay, so P of A union B will be equal to P by N plus Q by N minus M by N. But we already know that P by N is nothing but N of A. Q by N is nothing but N of B. M by N is what is M? What is M basically? M is this orange portion, right? It's an intersection. So M is intersection. So it is nothing but N of A intersection B. Everywhere divide by N is divide by N of S, divide by N of S, divide by N of S. Right? So N of A divided by N of S is nothing but P of A. N of B divided by N of S is nothing but P of B. N of A intersection B divided by N of S is nothing but P of A intersection B. So hence we got the formula that P of A union B is nothing but P of A plus P of B minus P of A intersection B. So this is the formula I want you to prove, and this kind of proofs will come in the exam for 5 marks or something like that. So similarly, if note if A and B are mutually exclusive. That means uh, there is nothing in common between A and B. Okay, implies A intersection B is empty, and therefore, if this is an empty set, P of A intersection B will be zero. So this guy will be zero. Therefore, in this case, in the case of mutually exclusive, you'll also get a problem. What define mutually exclusive? Okay, what is mutually exclusive? If A and B does not have anything in common, it means that A and B are mutually exclusive events. So in this case, P of A union B equal to P of A plus P of B. That's all. You have this little formula for mutually exclusive events. So this is uh, proof number one, proof number two. So like that, there are quite a few proofs you have to give. So I'll give some more proofs eventually. So next thing what I want to say is prove that for any event A, in a sample space S, prove that 0 less than or equal to P of E less than or equal to P of less than or equal to 1. This is the question. So I'll try to solve this. So consider this. This is a very important step. Consider uh, the fact that E is an event in the sample space. So E is a subset of S, and because it is an event, it could be either an empty event, nothing, or it could be something like this. So E could be equal to 5 also. E could be equal to the whole of S also, or E could be something in between. Okay, these are the three possibilities. So now, if you apply n on each, I'll use n of 5. I'll use the orange n later on for number of elements in 5 is less than or equal to number of elements in E, less than or equal to number of elements in S. Okay, so I'll write the yellow or orange and whatever. This colored n is for number of elements. Okay, or sometimes we also write as mod of 5. Mod here in the set theoretic sense means size of 5, the number of elements. So less than or equal to mod of E, less than or equal to mod of S. You can either write like this or like this. Both are okay. Same. So now this implies, I'll continue the n notation. N of 5 divided by n of S less than or equal to n of E less than or equal to n of S less than or equal to n of S divided by n of S. So again, I'll use the convention that the yellow n is for the number of elements. Yellow n. I just use this because in the last problem it was confusing which n is what. Okay. So now we have a clear thing that the leftmost thing is that nothing but P of 5. And the middle thing is P of E. And the last thing is P of S. Now, the null set will always have probability 0. Okay, and P of E you can write as it is. And the full set S, full sample space will always have probability 1. Therefore, what we have just proved is that the probability of E always lies between 0 and 1. So the next little proof that we have is another problem. I'll do it in the next page. P show that this question show that P of E bar is always equal to 1 minus P of E. So the idea here is, what is E bar? What is E bar? E bar is nothing but complement of E. So uh, complement of E means what? The set of elements not in E, right? So consider this Venn diagram. You have the sample space S and then the event E. So P of E plus P of E bar is nothing but this entire orange portion. The is this orange shading that I'm doing. This is your E dash, E or E bar. So if you look at P of E and P of E bar, or I'll not write P, I'll erase something. So what we can do is E union E bar is the whole of S. Therefore, P of E union E bar will be P of S. But by our earlier theorem, E and E bar are two sets such that they don't have anything in common. Whatever is there in E is not there in E bar. So we can say P of E plus P of E bar is equal to P of S. But we know that P of S is 1. So P of E plus P of E bar is equal to 1. Therefore, P of E bar is equal to 1 minus P of E. It's a very simple proof. You can use this proof. Or you can even give another proof saying that P of E bar, this E bar, I'm underlining this E bar is nothing but probability that the event E does not occur. So in that logic also you can prove this is a very simple proof. Okay. So next, I want to discuss a little bit of random variables. So these are very important in the sense that in the question bank you have several questions like this. So for a random experiment, like let's say tossing 3 coins, we can develop a random variable. There's so many ways of let's say observe the number of heads. So this is a random variable. So for each possibility here, we can look at its probability. So what are all the possibilities? You could, for 3 coin tosses, you could have 0 heads, or 1 head, or 2 heads, or 3 heads. Okay. So this is all the possibilities. So list out all the possibilities in the first row. And in the second row, what you do is uh, identify the probability. What is the probability of 0 heads? It's exactly 1 by 8. You can identify because it's the 0 is nothing but the event that TTT happens. Okay. So one head happens if it's either HTT or THT or TTH. So this is clearly 3 by 8. Right. So two heads will happen if it is HHT or HTH or THH. Again, this probability is 3 by 8. So we usually write random variable tables like this. The X is the random variable, usually capital X is used, and P of X is the probability of that run. Okay. So X P of X. So for x0, 1 by 8, for x1, 3 by 8, for x2, 3 by 8, for x3, it is again 1 by 8. So this is your table or a distribution for the random variable. It's also called distribution. So once we have this, usually what is asked for you is find, 1 second, I have an issue. Yeah. So you will be asked, what is E of X? That is for this random variable of observing the number of heads, what is the expected value? So please look into these definitions. I'll also, by the end of this lecture, I'll also give you the reference. Expected value of the random variable, also called expectation of, that is nothing but sometimes also called mean. It is given by the summation xi. I would call it as xi also. So this is x1, x2, x3, x4, and then multiplied with corresponding probability. So x1 ka probability 1 by 8, x2 ka probability 3 by 8, x3 probability 3 by 8, x4 probability 1 by 8. So do it because we have four such things. I running from 0, whatever, yeah, 1 to 4, whatever. You add all the four possibilities, and you soon see that it is 0 times 1 by 8. That is the first, this first thing. This multiplied by this is this. Similarly, 1 multiplied by 3 by 8 plus 2 multiplied by 3 by 8 plus 3 multiplied by 1 by 8. And that summation is simply what? 3 by 8 plus 6 by 8 plus 3 by 8, which is 12 by 8, which turns out to be 1.5, right? So 1.5 is the expected value of this random variable. Okay, so you can tweak this problem. In the exams we could tweak and say that for each head you will get a reward of 5 rupees. So that time you change this, uh, rather than counting the heads, I would say count the number of rupees. So 0 heads is 0 rupees, 1 head is, let's say, 5 rupees, 2 heads, let's say 10 rupees, 3 heads, let's say 15, it is 15. If 5 rupees is awarded for every head, then automatically the expected value will not be the number of heads expectation, it will be what? Expected reward. So like that we tweak the problem. So please look into the reference material, you will get more such problems. So similarly, you do another calculation. What is var of x? Var of x is nothing but variance of the random variable x. Variance of the random variable x. So variance is identified as var of x is equal to e of x square minus e of x the whole square. Okay, so here there is another one more layer to be added. Rather than taking expectation of x, you take expectation of x square also. That means, suppose this was your random variable, so 0, 5, 10, 15, I'll write it again, 0, 5, 10, 15, and it was 0 by 8, 1 by, what is that? I think 3 by 8, I guess. Yeah. So one head is 3 by 8, 2 heads is also 3 by 8, and 3 heads is, I'm sorry, I made a mistake, it's 1 by 8. Yeah. So now this is your x, this is your p of x. Now you also do x square. I'll rather put it on the top row. You do it like this. 0 square is 0, 5 square is 25, 10 square is 100, 50 square is 225. So rather than like taking this into this, you now take this guy into the probability, this guy into the probability, this guy into the probability, this guy into the probability. So what you do E of x square as summation x square pxi, I running from 1 to n, which is simply 0 into 1 by 8 plus 25 into 3 by 8 plus 100 into 3 by 8 plus 225 into 1 by 8. So which will be 0 plus 75 by 8 plus 300 by 8 plus 225 by 8, which turns out to be 375 plus 225, 300, 600 by 8, right? Correct. So which is on an average, oh yeah, this is not yet variance. Let me complete it. So right now this value turns out to be 8 sevens are 56, 40, 75. Okay, so this value has come out to be 75. Now E of x, I did not do it. So E of x is what? 0 plus 5 into 1 by 8. By the way, I'm doing another problem where I replace number of heads to the award. 5 rupees for one head, 10 rupees for, I think I made a mistake. This is 3 by 8 plus, yeah, again 3 by 8 plus 15 rupees for 3 heads. That probability is this. So it turns out to be 15 by 8 plus 30 by 8 plus 15 by 8, which is 60 by 8, which is 7.5. So expectation is 7.5. Where expectation of square is expectation square is 75. Just expectation is 7.5. Therefore, var of x, I said var of x is nothing but summation xi square pxi. Okay, I'll write a simple one. E of x square minus E of x the whole square. So E of x square I got 75 minus E of x I got 7.5. That has to be squared. So the final answer will be 75 minus 7.5 square. Let me see what is 7.5 square. 7.5 56.25. 56.25. So which is the variance now we found out is 15, 3.25, 3.75. So 18.75. This is your variance. So this is how you find out variance. Earlier I taught you how to find expectation. And for variance, you need both expectation of x square with also expectation of x. So this is the formula for variance. So please note it, guys. You will get problems on sum of, that is 2 compound probability. You will get problems on P of A minus B, P of E bar, such things. And also you will get problems on this variance and expectation. All you have to do is form this table. Sometimes in the problem itself, the tables are given, and find expectation and variance. Okay. So one small thing I'll try to say sometimes you'll be given this kind of a Venn diagram, or maybe you through the problem you can imagine this Venn diagram. Let's say there are two events. Let's say event A and event B. Let's say P of A is given to be zero point 0.7. P of B is given to be 0.4, and let's say P of A union B uh, is 1, which means they are exhaustive and they are the only two events of the sample space. Then find P of A intersection B. Then you can clearly use the sum formula. P of A union B is equal to P of A plus P of B minus B minus P of A intersection B. And we are given that the left hand side is 1. Sometimes it is not 1. Okay, this is a very special case, but here we are given that left hand side is 1. P of A is 0.7, P of B is 0.4, and I don't know this. So let me keep it as x. Therefore 1 equal to 1.1 minus x. Therefore your x will be equal to 1.1 minus 1, 0.1. Therefore the required probability of this intersection, the orange region, is probability of A intersection B is computed at 0.1. So such problems where you need to put the Venn diagram will also be appearing. So please look into these problems. So I just created this short thing for you guys to be helped. So that's it, guys. Please check this video and prepare yourself. All the best.